So wonderful.
It's so funny. Okay, let's see. That might be it. Okay, somehow we figured it out. Awesome. Let's get started. Without further ado, Paul is here. I am really excited about this webinar. So much to our expert panelists for teaching us all about the innovations that are happening in mass timber. There's a huge buzz. I actually was on a webinar, listening to a webinar yesterday that Illinois has to have mass timber buildings in here, no longer afraid of the being, and the fear of the Great Chicago Fire, but that is coming to an end, which is great. Today I am joined by Rachelle Habchi and Paul Mayencourt, our expert mass. And I'm going to give you guys a couple of seconds just to introduce you. So Rachelle is going to lead presentation. So I'm going to have Rachelle, I'm going to have you start off by just tell us a little bit about you, your expertise in the area.
Yeah, thanks. I'm a project engineer and director of sustainability at Glotman Simpson. Glotman Simpson, our main first office is in Vancouver, British Columbia. But I'm based out. We also have other offices in Canada, and I'm based out of the Los Angeles office. And yeah, we are an SC 2050 affiliated firm, which was also one of the driving factors for having this position, director of sustainability.
That's great. That was great. And then Paul is going second guest. So Paul Mayencourt, can you introduce yourself?
Yes. Nice to be here. My name is Paul Mayencourt. I'm a professor of cooperative extension at UC Berkeley. Work in design, so I have an appointment between forestry and architecture. I teach architecture students how to design wood buildings and structures, and I am a researcher in the forestry department at UC Berkeley. And I'm excited to be here, talk about mass timber.
Thank you so much. And Paul, please tell us a little bit about yourself.
Well, I'm just by a few miles here in Oakland at Jack London Square, right above the Produce Mart. oWOW is a vertically integrated real estate company, development, design, build, and property management. Our mission is to create sustainable urban living for the missing middle. That is, people making between 80 and 120% of the average median income. Our concept is to build high-rise housing as we're utilizing standardized units, prefabricated components, improving supply chain, and an innovative mass timber structural system based upon the Ferris lumber mass ply panel. Currently, our products are built at about 30% less cost than a comparable high-rise concrete building and approximately 30 to 40% faster than traditional construction, with a future goal of hopefully getting it down to about 50% reduction in cost and schedule.
That's great. And when I was in Oakland, I think it was this summer, Andy gave me a tour of one of the projects they're doing in downtown Oakland. So very cool to see it all come into fruition.
1510 Webster, and I'll get into very specific pictures of that. It was amazing in that those tours, Jory, were very short-lived because we started putting up our wood panels May 4th and on the 3rd floor, and we got to the 18th floor, the last panel, and set it on August 2nd. So less than 3 months, and we went from the 3rd floor to the 18th floor. It was amazingly fast.
That is fantastic. I can't wait to hear about it. But without further ado, I'm gonna stop sharing, and Rachelle, and I'm looking forward to this.
Can you guys see my screen? I'm assuming that you can see my screen. Thanks, Dory, for the great introduction. I just wanted to take a moment to say I learned about Urban Machine, like I think at the end of last year or beginning of this year, and I think it's such a cool company. I'm really excited to be here, and I'm really excited to be a part of this. I think Urban Machine is a great example of using like emerging technologies to advance sustainable building design, and to provide something in the market in order for like engineers like me to be able to specify reused material. So I'm really excited to be here. And just a very quick, a really quick introduction. Well, let's see if I can get to the next slide. It won't let me get to the next slide. Sorry, one second. All right, there we go. Okay, very quick introduction. I talked about myself. I have a lot of experience in different types of building design. A lot of the mass timber that we do currently in the Los Angeles area has been from creative office use. In Vancouver, we're also working on towers or and residential buildings, creative residential buildings. I am the chair of the SEAS Sustainability Committee currently for this year. I help co-lead the Carbon Leadership Forum in Los Angeles, in the Los Angeles hub. And like I said, and I'll talk about it, that Glotman Simpson is an SC 2050 company. And I'm a part of this really great embodied carbon working group with AIA California that helps to advance policy, which is super important, especially for mass timber policy surrounding embodied carbon. And just to put everything into perspective, why we're here, and why is everybody tuning in? About 40% of annual greenhouse gas emissions come from the built environment. 10 to 13% of that comes specifically from embodied carbon, which is where structural engineers can make an impact. And so, and that leads into SC 2050. So SC 2050 is, if anybody has heard of Architecture 2030, it's SC 2050 is very similar, except we gave ourselves 20 extra years. SC 2050 is on a mission to transform the practice of structural engineering in a way that is holistic and firm-wide, project-based, and data-driven. And when you commit to that, one of the main ways in which we do that is we have to submit these annual ECAP reports called their Embodied Carbon Action Plans reports. And it's this accountability that helps keep moving firms forward towards being net zero by 2050. And these plans are the accountability that is required of these plans. We have to submit them to SC 2050 every single year, telling them what we did this year and what we plan to do next year. I think is a really big driving force in changing the industry on the design side. So I look it up, SC 2050, great program. Okay, diving into, I think design policy really is a driving force of design on the design side. For I think embodied carbon and all materials in general, but it's very prominent in mass timber for a variety of reasons, in which I'll go into. So British Columbia. So my company is based out of Vancouver, British Columbia. British Columbia, for multiple reasons. One of them being that they have a lot of our mass timber is sourced in British Columbia, so they have a lot of resources to be able to implement action towards mass timber. British Columbia has been really great in advocating for increased design in mass timber. They created this mass timber action plan, and the plan is focused on the people and the economy and the climate. And what's really interesting about this plan is it's a key role in their Stronger BC economic plan. So what the province is basically saying is that they see the implementation of mass timber as a direct correlation of the economic growth of the province. And so them tying that in with each other makes it so that mass timber can be more easily implemented on the policy side and on the funding side. They created the Mass Timber Advisory Council, which basically the job of the council is to make sure that the Mass Timber Action Plan is taking into place. And then they have this Tallwood Initiative that allowed design firms and developers in the province to adopt new provisions for mass timber about 2 to 3 years earlier than the code was put into place. So that's why you see more than 200 mass timber buildings in British Columbia. And another policy that British Columbia provided was this mass timber demonstration program. The program provides funding to support the design and construction of mass timber buildings that demonstrate emerging or new mass timber building systems and construction processes. And one of our buildings personally, M5, was a part of this program. And the developer was able to receive funding in order to provide a really cool looking building made out of mass timber. And I'll talk more about M5 later on in the presentation. When it comes to and again, this is policy related, design related, especially with mass timber. What your building ends up looking like in the layout is very heavily tied into the fire rating considerations. And so before IBC 2021 fully vetted and standardized mass timber through these 3 graphs that you see using type 4 construction. From before, it was heavy timber was treated as light wood frame or type 4 HT. Personally, for a project I'll show you all in a bit that we did before IBC 2021 really standardized it, we had to construct the project as type 3B in order to be able to fully expose the beauty of the CLT in the project, and also in order to meet the fire rating. And so what that limited it to was less than 6 stories, or up to 6 stories above the podium and 75 feet in height. So it limits your height, and when you limit your height, it also kind of limits. It inherently kind of limits the developers that may be looking to benefit from mass timber. So in IBC 2021, now you see that you can build up to 18 stories. However, unfortunately, as you get up higher, the more protected that the mass timber has to be. So for like type 4A, when you have 18 stories, it has to be fully protected, exterior and interior. The exterior walls and the structural frame require a 3-hour fire rating. So it's not really as exposed. Whereas when you have like shorter story buildings, things can be more exposed. And people, the residents in the building or the occupants in the building, can directly benefit from being in a place that has mass timber. And being in a natural environment, natural materials. So what we've done at Glotman Simpson is provide this GWP comparative analysis for sustainable efficiency. It's used at the very, very preliminary stages of the project. That's when really we can be helpful as structural engineers, I think, in providing guidance on whether we can, on what a mass timber building would look like, and we provide these comparisons. Obviously, there's other considerations that the developer and the architect have to consider when deciding what kind of material they're going with, but this has been really helpful in just providing additional information on the global warming potential intensity for different systems. And when it comes to global warming potential intensity, a lot of times mass timber wins. So I talked about 843 North Spring Street slightly. One of the really big design considerations when it comes, this is our project, it's a creative office use space in Chinatown, Los Angeles, so really close to downtown Los Angeles. It's almost completely built now, and it's insane how the real life building looks so close to this rendering, and it just speaks to the beauty of mass timber and CLT. This project was a hybrid mass timber building, so you use CLT framing with steel. You see these black steel beams so black steel framing. And one of the primary reasons actually this was used was because this building was also an adaptive reuse. The podium level, let me see if I can use my laser pointer. Yeah, so the podium level is at this level, and so everything below was existing concrete. The design tried to, and then you have also one grade below of parking. So the design really tried to preserve all of the existing concrete, and specifically due to the lightweightness of compared to a traditional like steel frame with concrete metal deck, the lightweightness of the 5 stories above the concrete podium, we were able to preserve the foundations and avoid a full-scale demolition and excavation of the existing structure. So it was able to become an adaptive reuse. The design saved about 30% of the 30% of the existing concrete and 30% of the total concrete that ended up going into the building was existing concrete per the design. And that was directly attributed to the CLT being lightweight enough to provide to be able to use existing footings and just make them larger. And yeah, so I think the lightweightness of mass timber is not as it's something that should really be taken into account during design. And again, another design consideration is vibration. And that also kind of ties into, I'll talk about it later on, but a lot of times especially for creative office spaces, we have to provide this lightweight concrete topping in order to meet vibration considerations for the occupants. And the concrete topping used to act as a diaphragm before CLT was able to be considered useful for diaphragm and size like a seismic diaphragm. But now it also functions. It functions for vibration, and then when you have these exposed structures, you're also able to route conduits through the lightweight concrete topping. So you have a lot less like MEP in the ceiling space next to the beams, and you just expose the beauty of mass timber. So going into design considerations of specifications and reusing of mass timber, you really have to look into specifically like the structural integrity and strength. And one of the things I think that Urban Machine does really well is they regrade everything that they reuse. So us as like structural engineers, as long as it's regraded, we can end up using it. It's really important to have a modular design. It's really crucial in order to, especially if it's intended to be used for deconstruction and reuse. And then when you are considering reused lumber, a lot of times you have to consider the treatment and the condition of the timber. So you have to evaluate whether preservatives are used, fire retardants, or coatings. The moisture content, which I'll talk about in a little bit, is really important. Connection systems, like using low emission adhesives. This was something I learned from Urban Machine, which is removing it's really difficult to remove the glue from existing lumber. And from what I know, almost all modern construction, almost all current timber construction where you use like plywood and joists in order to mitigate the creaking that happens, they'll glue the top of the joist to the underside of the plywood, and so that makes it really difficult to reuse. And then I think another consideration is that I'm interested in is long-term deflection and creep. So I think in order to be able to really specify reused lumber, you have to really understand the load history of when it was used. And so I think it'd be interesting to provide load history analysis as a part of the construction documents if the intent is to design for deconstruction and reuse, because the environment in which the timber was used can affect its mechanical properties and it can contribute to creep. And then specifying different grades of mass timber is really important because or specifying specific grades and species of mass timber is really important, because different species are more susceptible to creep, like maple, beech, birch, and spruce. They're more prone to moisture-induced changes, which can exacerbate creep. So specifying things like Douglas fir where they're less prone to moisture-induced changes, would be more beneficial long-term. And Jory, please stop me whenever you want. I know I'm a little bit over time, and I'll try to go a bit faster. Designing for deconstruction and disassembly, I think it's the devil is really in the details and in the connections. Standardizing sections across projects is really important, and standardizing the layout in the rectilinear grid is also important. And that's actually something. This is a really cool building that we're working on currently, and the connections that were created are just really fascinating to me. So the way that we modularize the building is that we have these glulam columns, and so MEP routing is a huge consideration when it comes to mass timber. Like I said previously, you can use the concrete topping to route smaller, like 1-inch conduits through it, but then you have these larger these larger pipes that you need to route through the floor system, and especially when everything is exposed, everything has to be well coordinated. So for this project, we came up with this really cool connection detail, and it allows for easier disassembly. Even though it's using screws and stuff, you have this typical connection, this typical girder to column connection that is used throughout the project. The whole project is modular. The layout of the project is modularized to have these two glulam girders come and bypass the column and then sit on these little, I guess, saddles, sit on these little saddles for that support, and then bring that load back into the column. And then, so that's the main girder system. And then we have beams intermediate in between the girders that go over the girders, or frame into the girders, to provide, to reduce the span, to provide a secondary support for the CLT. But designing something like this, even though it's a cut. Oh, sorry.
I was going to say,
Did I?
a major part of what focused on today is just how to make it possible that this wood can be reused. So I really appreciate that that presentation. I feel like I learned so much.
Yeah.
But I want to make sure that everybody, give everybody ample time to share their presentations. Do you have any last thoughts, Rachelle? Like something that you want?
I would all these slides just talk about they talk about connections. I did do an LCA on the M5 prototype, just to that M5 prototype that I showed previously, that was a part of that funding program. It was 18 stories of hybrid steel, a hybrid mass timber system that sat on a podium at like the level 3, and it just highlights how much global warming potential is coming from the concrete, the metals, and the wood portion. Basically, what I wanted to talk about was that policy, like in Vancouver, their new embodied carbon policy, the reuse of salvaged materials. If you do that in your design when you're doing an LCA, they can be excluded from all of the life cycle stages. So you get an immediate decrease in your global warming potential, whatever that may be, due to the wood, if it's reused. So that's super helpful. And yeah, that was basically it. Yeah, sorry for the long presentation.
No, that's I really appreciate your passion. It shows how much you really this is not just a job. You love what you do, and you definitely are showing it in your presentation. I know people can reach out to you if they have further questions. And I just want to clarify one thing. Urban Machine, our robot, is removing all the metal fasteners, construction wood waste, so that wood can be reused. And we're very confident with our regrading, and we're working on technology for the structural regrading piece. So I just want to clarify that we're not, but we're working on it. And Paul knows all about it because we've been working our machine on some projects, plural. But the big one is making DLT out of, or the one that is most relevant here is about making DLT out of reclaimed wood. Further ado, Paul, you want to share your screen and explain there at University of California, Berkeley.
Sure. Thanks. Let me just set that up. And then...
reminded me that I didn't introduce myself. I'm Dory Wisniewski. So excited to introduce all of you that I kind of forgot all about myself, and I'm the marketing manager at Urban Machine. But I've been in the wood industry for a while now, so I consider myself a bit of a lumber nerd. Presentation's up.
Can you see my presentation now?
Yes, we can.
All right, great. Well, I'll present a bit on, as Jory mentioned, we've been working together on a project to bring DLT to California, and with a focus on reusing or using salvaged lumber. And this presentation is kind of like the progress we've been making over the last couple of months on, bringing the tools pretty much to enable the fabrication of DLT made from local lumber, either from local forest or from salvage sources like Urban Machine is providing to California. A bit before that, I just want to give a quick introduction on my work. So I've recently started as a Professor of Extension, Cooperative Extension at UC Berkeley. So part of my work is helping companies like Urban Machine to, bring more mass timber in California. And I do also academic research on engineered wood products and design. So this is a picture of pretty much when I moved to California a couple of years ago. And for me, it was really telling. I was coming out from my PhD in structural engineering and architecture, focusing on mass timber. And I came to UC Berkeley to learn about forestry and the impact on the environment and how we can source materials in a way to reduce the embodied carbon of buildings. So I was really interested in looking at alternative sources of building materials, either local forests or, lumber that is coming from deconstruction sites, we're working on now with Urban Machine. And there's really two things that, we're kind of fighting to each other. Is like one side you have the forest, and one side you have the built environment. And the previous picture showing the orange sky was kind of like the clashing of the two, where our, disconnect with the climate was impacting our built environment. But instead of being a clash, it could be a, complementary resource to help one another. And the idea is that, on one side, we have carbon emissions coming from wildfires in forests in California. And this is an insane number, but the wildfires in 2020 have negated reduction over the last, I forgot the exact numbers, but pretty much I think the last 10 years. So all the efforts in reducing climate change in California has been negated by 1 year wildfires. So wildfires are important source of carbon emissions in the state, and we need to do something about it to make sure that we can reduce the carbon emissions of the state of California. And then this was mentioned before in the previous presentation, but the built environment also has a large impact on global greenhouse gas emissions, both from how much we put energy into operating buildings, so operational energy or operational carbon, but also embodied carbon, so how much carbon we produce or emit by creating construction materials and building our cities. So instead of being a clash, maybe we can have something that. But one of the challenges here is that on one side we have forests and that means to reduce wildfire risk. That means we need to get small diameter trees out of the forest, and also we need to use more of underutilized timber species and sources. And from the construction site, in order to have lower carbon designs and materials in the built environment, we need to make sure that it can be affordable, or because a lot of the solutions now are costly to implement, even for the technology that makes it lower carbon, or some designs in mass timber still challenges a bit the existing models where it might result in being more expensive. And we see a lot of places where mass timber is being challenging to make it affordable. So I'm excited to see the next presentation by oWOW, because I haven't seen the new building. So I'm excited to see how this comes out. But my work at UC Berkeley is trying to find a way to better utilize wood that we have in our local forest to support forest management. So the question is, how do we take what needs to be taken out of the forest and make wood buildings out of it? And the idea is nothing new, but it's how do we solve the engineering and design challenges so we can have high added value building products to make sure we can support forest management. And the two main topics of my research is low carbon engineered wood products. So how do we produce and make mass timber products that have an even lower footprint on the environment? And another aspect of my research is taking elements of farm to table that has been really successful in agriculture to bring more sustainability to agriculture and the way we produce food, and apply these principles to something that I'm calling forest to frame. So how we connect the source of materials to the end use in the building as a design framework. And what I'm going to present today on is the Dow laminated timber for California. So the work that's been happening over the past couple of months with Urban Machine. And really, it comes from the realization that there's a lot of interest in California to have mass timber projects. So this is from a report that was recently published by the Board of Forestry and Fire Protection in California, where we have about 180 projects that are either built or in design in California. So that's a lot of interest in mass timber projects, but we have no mass timber manufacturing in the state of California. So, if we have, it's very little small shops that, don't produce the type of mass timber products that are being designed with in these projects. So really hard to find any mass timber products in California. And part of my job as this position at UC Berkeley is how can we bring more manufacturing in the state so that we can use local forest. And one of the focus is focusing on distributed small-scale mass timber manufacturing. And part of the idea is coming from this idea of taking ideas from the farm-to-table movement or agriculture, where we can see that small farmers are responsible for quite a bit of production of food supply worldwide. And we've seen in the past what has happened with some mass timber manufacturers, that going too big could be very challenging, both because you need a very steady supply of forest logs in the same location, and you need a lot of investments to make it work. And I think it's been challenging in the past couple of years, although everyone knows that mass timber is desired in the States. There's been no one wanting to, build mass timber manufacturing facilities, or at least there's no one that's done one so far. And the idea of distributed manufacturing is nothing new. It's happening in a lot of countries where the wood products market have been more developed. So this is an example from an industry in New Zealand. But if you look at examples of Europe too, there's a lot of smaller manufacturing sites that produce mass timber panels and mass timber products, almost like family scale or family owned mass timber manufacturing that provide enough mass timber construction panels for the area. So the idea here was to focus on small scale NLT and DLT manufacturing for a couple of reasons, because it's a low initial investment. It's a very simple manufacturing process, and I'll show some pictures of it in a few minutes. And then it also requires a lower skill levels than other engineered wood products like CL2 and LVL because of the glue that are involved in these products. So the manufacturing processes are a bit simpler, especially for NLT, where you're literally just nailing boards together to make a product. And one of the big interest or reason why we focus on NLT and DLT is it's already in the codes in most places in California where this is recognized as a building product. And I'm currently at the Richmond Field Station, the old site of the Forest Project Laboratory on UC Berkeley's campus. And the buildings next to me are all NLT panels. So the whole building is built with NLT. The technology has been around for a very long time. That's really well known, really easy to make, and it's already in the codes as mechanically fastened timber panels. So it's a good first step to kind of bring manufacturing of mass timber elements in California to do it quickly too. And the one we're doing now with Urban Machine is mostly dowel laminated timber. So the board together and laminated by pushing dowels through holes, and the dowel keeps the panels together. The dowels don't really have a structural function. That's why they go through the middle of the panel. They just help the board to be held together. But the wood is acting as the main structural function. There's some exceptions in depending on the design of the panels, but mostly we're relying on the strength of the wood to be able to carry loads. And this is one example of a DLT building. It's really easy to use. It doesn't have two-way load current capacity like some other products like CLT has, but a lot of very successful designs have been built using a NLT or DLT, and it also relies on lower grade wood or also a simpler manufacturing process. And the thing that was interesting to realize when we started talking about this with Urban Machine is that there's no mass timber manufacturing in the state, and there's a lot of focus on trying to bring CLT to California. But it's been really hard talking to a lot of people to find the funding, but also the skill level, so it's the skilled workforce to actually do it. But DLT is actually really easy to make. As you can see here on this diagram from StructureCraft, the manufacturer that's up north in Vancouver, BC, where you press boards together, drill some holes, push the dowel through, and then you have a panel. And some of these panels are made by a machine produced in Switzerland that I went to visit last summer. So you can see here the production machine by Holmag. There's other machines in the industry, but this is one that I believe is being used by StructureCraft. One of the issues with this machine, it's very costly, $2 to $3 million just the machine, and then you have a lot of other costs associated with it next to it. But also it is a lead time of 2 years to get the machine. So if you want to act fast in terms of providing California with sustainable building products, if you look at that time frame, it's a bit long to start manufacturing panels in California. So the idea was to focus on something smaller scale that we can do pretty quickly. And see here some other pictures from the fabricator I visited in Switzerland, Kunz Holzbau, that I highly recommend to go visit because they are probably one of the nicest fabricator that I've seen in a long time. And here's an image of the large CNC machine they have. That's something that's usually required or really well appreciated and together with the machine so that you can machine the panels. But you can see here the scale of the machines and some detail shot here. That was an inspiration for the machine I'm going to show later that we've been working on with Urban Machine. As a first step, I think what was important to do here is do a bit of education and showing people like we can manufacture dowel laminated panels in California. So I'll have a few pictures, but this is the tools. It's less than $500 to make panels that I've made here at the Roofing Fill Station, where you can just stack the wood, mark the location of dowels, like clamp it together, drill some hole to the pallet hole, get the pallet hole, drill the hole stack with a drill, and then hammer in the dowel, push it through, and repeat until you have completed a whole DLT panel. And then you can trim the dowels, and you have a couple of DLT panels. So this is what have been happening just behind me here, showing that it's not that complicated to make DLT panels, and these technically could even go into real buildings. They have slight imperfections because they were handmade, but it's just to show that it's not that complicated to make these panels. And with the skill level required, you can also imagine a very simple shop where you can manufacture these panels with very low skilled labor. And I've been teaching a couple of people already how to make these, and there's a lot of interest in how to make these panels. And the next step here is this machine that we've been working on with Old Bay Lumber and Urban Machine that's been designed by Dees Design and Engineering, where we've taken inspiration from the machine in Switzerland and learned from making these panels in the shop here to make a small scale, simpler machine that doesn't cost a couple of millions, but maybe closer to $100,000 to be able to make DLT panels in a small scale manner. So we're really close to having the machine ready. this is the construction drawings of it, and hopefully we'll be producing some panels next year using some of Urban Machines lumber. So this is kind of like a hope for 2024 that, you know, we'll have DLT in California next year. Thanks for listening, and happy to take any questions either now or later, or you can also email me. Thank you.
That's great. Paul, I'm going to drop your email since you said that. I'll drop your email in the chat on LinkedIn, and that way they'll have some questions. They can.
Yeah,
It's
perfect.
exciting, and it's good to hear.
Yes,
that
I
everybody
agree.
Yeah, I love it. Thank you so much. We'll let you go from here. Thank you so much.
Great, thank you. Well, those both very interesting presentations from Rachel and Paul, and you both had some content that you'll see in mine. I know we're short on time, so I'm going to go through these very quickly. I can figure out how to do it. There we go. I already told you about oWOW. Rachel already told you about the type 4 building codes. We have buildings in each category. The one that I'm going to focus on today is our 1510 Webster building, which is type A. And it's really unfortunate that type A requires you to cover up everything with 3 layers of drywall. And it's little ironic when we took one of the code members through the building that she said, it's such a shame. This material is so fire resistant, but there were a lot of special interest groups writing these codes, and they really went overboard in requiring the cladding. We're using mass ply panels. Mass ply are different than CLT, DLT, or NLT in that it utilizes 1/8-inch veneers, and they're peeled from logs. And the logs that we can use for that are what Paul referred to as the small diameter trees that have been causing our massive, not just forest fires, but fire storms, because they're ladder stock. They're 6 to 8-inch trees that allow the flames to get up in the canopy of the old growth trees. Forgive the train in the background. There's going to be one going by about every 5 minutes. Hopefully that doesn't interfere with being able to hear me. It's great that the forests are being managed now in a more responsible way and starting to cut out these smaller diameter trees. And it's great that we can use those smaller diameter trees and build these panels that have high value. We did independent testing and found that we could actually get up to 2.5 times the load and even higher in punch shear between a CLT panel and an MPP panel, which can be built up to 12 feet wide and 48 feet long. We also did fire testing. It's amazing that you really can't burn this stuff. It's non-combustible, although it's not listed as non-combustible in the codes, but you can't catch it on fire. It chars up, which then insulates it and really prevents it from burning more quickly until that char layer falls off. As previously mentioned, it's amazingly beneficial for the environment. We saved about 5,000 tons of CO2 from going into the air by utilizing mass ply panels in lieu of concrete. So for every cubic yard of concrete that is replaced by a cubic yard of mass ply or mass timber, you're preventing 2 tons of CO2 from going into the environment. Mass ply is actually much more efficient than CLT in that you're not cutting rectangular shapes out of a round tree, which results in 20 to 25% waste, but you're peeling it, and it comes down to a 3-inch core that's used as a grapevine stake. The outside bark and other parts are actually burned in a biomass facility. All of the nitrous oxides are taken out through a electrostatic precipitation chimney, and that drops to the bottom of that, and the resulting waste is used in fertilizers. So it's amazingly efficient. It's a zero net waste, a zero net energy product. Freris, I'm talking about, you can see that the logs, that's about an 8-inch log going into the plant. It's peeled, graded. They have a mill. They have 17,000 acres of land there in Oregon, which is about 580 miles away from us. Here's a quick video. That's a pretty informative video. As Rachel was saying, Vancouver, at the heart of our case study, was Brock Commons, tall house, 18-story student housing, finished about 3 years ago, and Fasten Up was the engineer. It was really innovative in that it was a what the Australians call post and plate, point-loaded, beamless CLT, 5-ply, about 7.5 inches thick. The column spacing was 10 by 12. They erected the concrete cores, 2 of them first, and then put up, and that took about 7 months, and then they put up the mass timber superstructure. It took about 4 months. The finished building actually ended up being about $8 a square foot more than a comparable concrete building, and took about the same amount of time. But it was, in seeing the point-loaded structure, we thought that is incredibly efficient. That's what we want to use. We just have to figure out how to get the cost down. So we started off with the traditional exposed glulam beams in CLT, and realized that just wasn't going to work for what we wanted to do. This is a 5-story building. We built the first 2 floors under a separate permit, and then when we went back and put in the residential floors, you can see it was very different. It was a 10 by 12 spacing, but we're using mass ply panels. Came up with a custom connection, and we used a internal hardy panel that was a moment frame, and it was very cost effective and very fast. We did further testing up at WRD in Oregon, and keep getting this and get rid of that. Sorry about the blue beam trying to take over the presentation. But we learned that the structural values of that were incredible. Again, testing more than 2.5 times that of comparable testing on CLT. And the fire testing indicated that really we didn't need to have anything whatsoever in order to still maintain a full structural load after 2 hours of burning. And in fact, if you put on the 3 layers of drywall and burn it, the concrete structure, 8-inch thick slab, falls down before this mass ply panel does when it has the 3 layers of drywall, which is obviously gross overkill. Testing has been done that indicates that basically everything in an apartment burns and is done after about 20 minutes. So why we have 3-hour ratings when everything inside burns after half an hour, I don't know. We have a lot of work to do on codes, I think. The 1510 Webster structure that we're building, by comparison, after we did all the testing, we determined because we could eliminate a lot of the columns, because we went to a 5-inch instead of 7.5 inch, that we could eliminate one of the concrete cores, and that created substantial savings. We have a shear wall there instead of a core, and so the building with 16 by 12 foot column spacing is just a lot more efficient. And there you see the building. We're a little bit beyond that right now, but the one big core, the blade shear wall, 19 stories. We have actually a 2-story concrete podium with a basement level, 236 dwelling units, $72 million cost. That's $400 a square foot. So how does that compare to a concrete building? This quick summary shows you that if I take everything into consideration in a comparison, that we save about $4.5 million. That's a 20% savings overall in the concrete building. What started off as a $100 million building with concrete and curtain wall ended up with a building that we're actually building for $71 million. So substantial savings. I believe it's the only building that went to mass timber and actually was less expensive than concrete. But what we're trying to do here is to create a building that isn't an architectural wonder with a bunch of exposed wood, but it's a building that's actually going to be able to be used in downtown areas, urban infill, and provide a way for us to deal with the missing middle. The people, the majority of whom would love to live where they work, but they can't afford to. So we're trying to solve that problem. We use extensive BIM modeling, virtual design and construction to get to the exact placement and layout of everything that's penetrating these. And these are CNC'd up in the factory. They come to the site about 6 to a truck, and they go in at about 10 minutes a panel. Amazingly fast. We use a rotoblast pillar connection. We can set each column in about 3 minutes, and that connection is very cost effective, very fast. It's a wonderful, amazing connection. Thank you, Rotoblast, for that. We put them in right at the job site, so we don't have to go to a secondary fabricating facility. And the whole process is fast. We eliminated the routing at the edges with the plywood strips, and we just went with a Simpson strip, 18 gauge, and screwed it in place. That goes in very quickly. The drag struts back to the core. We broke those down into manageable pieces, and because we didn't want them to come up into requiring a topping slab, we routed it out and connected them underneath very efficiently, tying them back, welding them back to the cores. We have an edge diaphragm that serves as a pour strip as well as supporting for the cladding is unfortunate. It looks beautiful before, not so good afterwards. We put down a very thin 3/8" Acoustomat with a 1-inch gypcrete topping on it. So there is no structural topping slab. Amazingly good sound attenuating performance. Our panels, our exterior panels, fabricated in Canada, in Vancouver by Centura. Very simple rain screen system on metal studs, 10 by 30. Those take about 15 minutes per panel. They come vertically. We pick them right off the truck, set them in place with a 7-person crew, 15 minutes a panel, end up looking pretty good. That's the result. Very successful building. We've got 3 more in the works. We're starting in 2 months on 3403 Piedmont, which is basically an 85-foot tall, 4 code, mass ply panels, 960 Howard, San Francisco. This is 4B, and the next version of 1510 Webster is 1523 Harrison, and it will be 270 feet tall. So we're pushing the limits there, but everything we're doing is mass timber and mass ply. Thank you.
That was great. That was a lot of information in a short amount of time.
Yeah, I generally, I took a lot longer than that in Melbourne, about twice as long, but I noticed we were running out of time, so that was the short version.
Well, I really appreciate the information and that you were able to get it all in. I want to make sure that everybody, you guys can share your contact information and see if anyone has questions in this last few minutes, or if you have questions. We do have a comment on LinkedIn. Mark Hurst said amazing buildings, and I agree with him completely, especially having seen one in person. Andy, you're pushing the limits and not the just. And you're pushing the innovation and making sure that things happen. And I think we all is thinking differently on this webinar. You know, the status quo doesn't have to be the only way. And our founder, Urban Machines founder, one of the 3 founders, Eric Law, he came up with the idea for the robot because he was doing research, found out that 30 food waste go into landfill every year, and it was this light bulb. He didn't know that that's the way things had always been done, but it was like, no, we can do better, and we need people like you who say we can do better. So thank you all. Any questions for each other? I don't see any questions coming through online.
No, but Rachel and Paul, anytime you want to come down and walk through the building, take a look, learn more. Paul, you're right next door here, so if you want me to come up and talk to any of your class about anything, I know we've had several tours for Cal students down here through the building when the wood was exposed, but it's a natural relationship to have with great university. My son went to Cal, graduated about 5 years ago.
Yeah, I'd love to. And nice to meet you too. Thanks for organizing this, Jory.
Yeah, thank you, Joy.
Thanks, Jory.
Yeah, I appreciated this. If you want to check out Urban Machine, it's urbanmachine.build, and please reach out to any of these three for more questions. And thank you, Rachelle, Andy, Paul. I really appreciate you taking the time and
You're
sharing
welcome.
your knowledge. All right. Have a good weekend, everybody.
You
Have a
too.
good week.
Thanks.